Hello, good afternoon. Welcome to the stream. Hello, Evan. Long time no see. Hope you're doing well. Ah, so we got some interesting things to do today, I hope. Um, Last time we were busy trying to figure out why our collision systems were wrong. Um, I think we figured out it has to do with interpretation of the LDTK level, um, and where the boxes align on that. So um, hopefully we'll get a little bit better today. I don't know. We'll see. Um, we have we have some stuff that hopefully we can figure out. If that doesn't prove fruitful, maybe what we can do is back out of our more complicated collision system, simplify it a little bit, and then try to make it more sophisticated again. But we'll see. There's lots more that we can do in other areas of the game. I think that unfortunately with the design of this kind of game, um, collision systems are really important. Um, so hopefully it'll be feasible to get some good information here. So yeah, let's get started. I think I wanted to look at. I'm sorry, I'll share the other screen now. I wanted to look at what we did last time to get context. Um, so last time we re-enabled our camera following the player, and we simplified it. So we didn't have all this goop about LDTK and the level dimensions and all that. We just said, okay, the camera's transform is going to be the same as the player's transform, at least the translation. Um, and then so we got rid of all this stuff that is trying to figure out, well, where are we in the level. What we might be able to do instead is maybe we can um, add the bounds. Let me think about that. But we might be able to add the bounds on startup. So we'll see. That is less important than figuring out why our offsets were all wrong. So we did add this additional system which creates quads on top of anything that has a collider. So this will give us, and as well as where the center of the collision box is. So we have this kind of semi-transparent box that circumscribes the actual collision boundaries, but also there's another quad that is in the center of it, so that it can show how much we're offset from the center of the entity that we're working with. And I think what we saw, we might as well just run what we have right now without making any modifications. Um, what we saw was that on the walls, of course you can't see me moving that well, except for when I have it turned off. So our problem was this. We are really far away from the wall, and yet we're colliding. So we shouldn't be doing that. And then, yeah, so let's run that with gizmos. turned on. So now we can see these gizmos being drawn. Um, you note that in our, yeah, okay, and so this is interesting. It's actually down, and yet we're not even close to that box. So okay, but you'll see the interesting thing here is that our collision boxes on the other entities works fine. So it's just the walls that have been spawned by LDTK. And if we were to go and put like internal walls in this level, so like things that the ghosts and our character have to get around, that would make this even worse. So let's look at what we did here. Okay, so our left and right walls have a width of 6 and a height of our tile size, which is 16. And the left ones should be pushed to the left by 2 pixels. You notice on the top it should be pushed up by 4 pixels, but it looks like it was down. Let's real quickly change this. I kind of, because we did this so long ago in a different way, I'm kind of loath to do this, but let's try that in -4 and see where the box goes. It should actually push it closer to the player. Yeah, and so I don't know if you can tell, but it does look like it's closer to the player, but we're still way more than 4 pixels away from it, and we're colliding technically. So there's something wrong here with the computation of that collision. And maybe it makes sense to so we have some debug stuff going on here in the collision, right? Maybe we should go and add so that's in movement. And that is the keep inside walls. Where's that info? Okay, so we have a wall and it has a collider, and these are how they're overlapping. So the object has 895 1158 as the min. Right, so these should all be very positive. Let's look at, I want to look back at the wall collider. So the top, yeah, it should be positive because it's positive going up on our screen, right? So if we wanted to move it upward 4 pixels with a height of only 12, that should give us 3 pixels? No. Yeah, it's possible. So Evan was asking, is it something to do with the centering provided with rect at? Let's look at that. Or to rect at. Right. Okay. So we are taking. So this is given the transform. It takes the transform. So truncate cuts it down from a vec3 to a vec2. We add the offset to it, and then we rect from center. So this is from the center and the size. So what may be happening is that the grid is drawing in a different coordinate system than, and I think we've talked about this before. So what would be plausible? What would be plausible is that it's drawing the tile from the bottom left rather than from the center, which would make it, yeah, I think that might be part of it. Um, and remember, we were in um, our gizmo system here. We're making these child um, child entities of the things that have collisions. So um, their transform will be based on their parent transform. So maybe what we should do, um, maybe what we should do is look at the transform. That's part of the problem is I don't know what that's going to tell us. So like I want to see um, yeah, we may have to dig down into the crates drawing code, which is actually from Bevy ECS tile map, not from ECS LGK. Hi, Chris. In which case, I think it's probably, yeah. Let's go look at that. So um, let's look at its dependencies ECS tile map, because I think that there's something in here that I'm just not seeing, and it has to do with how those, like what the shaders are potentially, um, in which case it would be in here. And this is probably, yeah, okay. Because it seems fairly likely that if it's drawing from the bottom left rather than from the center of the entity, then it would look mispositioned with respect to the collision box. And that text size is too big. So let's see here. Transform changes from time map to chunks. Yeah. Chris, I don't know if you've dug into any of this pipeline for the tile map, but I would be curious if you know about the alignment of its meshes, because that seems to be where I think where the problem is coming from, and don't feel like I'm experienced enough with this to figure out why it might be offset in a strange way. So yeah, that's not really telling me that much. Look at draw. Let's see what it draws. Okay, let's just set bind groups. Transparent 2D. Draw a tile map. Okay. Material. there's a lot of very deep stuff related to the renderer, the Bevy renderer here. Not since the 0.12 changes, which I think changed a lot. Okay, yeah. So, Chris, I'll show the issue again. So we did last time, and I think you weren't here last time, which is probably didn't see it. We made some gizmos. Basically, just draw the bounding box of the colliders that we've applied to our objects in our game, and when we run with that turned on, you see we get the green boxes around our things, but the first of all, this alignment is incorrect. There's something else going on there. But if we get up close, we are not touching that, but we are actually colliding with it. So I'm not certain about if there's something seriously wrong here, or if it's like these tiles are drawing from the bottom, like the 0 point is the bottom left, or the bottom right for that matter, and it's drawing the quad up in that direction rather than having the anchor point at the center. It's transform anchor point. So that's my current suspicion. All this other stuff we did ourselves. So oh, and that's fun. I'm dead, and the ghosts just kind of float out. And it's not clear to me whether we're drawing this quad as a child entity of the tile, or and that, yeah. Yeah, I believe they did collision in the platformer example. Yeah, let's look at the platformer example. So, right, so they don't do it here, but it's going to be in the source. Then go back here. Let's just go to the repository. So the example. Let's look at the platformer example. Not very many files here. Okay, so they have a collider bundle. They're using Bevy or Rapier 2D. Probably it has a collider in it. And rigid body. Now we could convert to Rapier 2D. I don't know that we need the physics other than collision right now. Okay. So let's see. For the player, they create a collider bundle, which is a cuboid. I'm guessing that's the dimensions of it. Okay. Yeah, that makes sense. Okay, so they're doing some manual conversion from int grid cells to bundles. I was reading about that earlier. We don't need to do that yet, but let's see. Okay. In-grid stuff is mostly chess, etc. in that example. That makes sense. Probably oh, so they've got ground detection. They've got a wall which comes from in-grid cell, right? So that's sort of what we're doing. We've got a ladder which you can climb. Okay. And then yeah, we don't, that's just loading all this stuff. Okay, so excuse me, ground detection on ground, true or false. So okay, that's interesting. Let's look at their systems then, because this may give us some information. Okay, so they've got a camera bundle. They're loading the LDTK, as we'd expect. Okay, so in their movement system, they're right. So they're determining the x direction of the velocity. And this has got to be Rapier 2D's velocity, I'm guessing. So, okay, so then it's looking at, is this intersecting with anything? With anything that's climbable, like a ladder? Right, and then if they pressed up, I'm guessing, or down, yep, W or S, then they are climbing. That also means that it is intersecting with something that's climbable. If they're climbing, then it's okay. So you can only do up or down if you're climbing. And if you press space and you're on the ground or you're climbing, then you jump up at 500 meters a second. Okay. And you're no longer climbing. Okay, so let's spawns herring collisions for the walls of the level. I don't know what herring collisions are. Birds? um, so, okay. You could insert a collider bundle. The wall bundle that spawns a different collider for every wall tile. Right, and this is something that we saw early on. Old physics high level library. Okay. This leads to bad performance. Instead, by flagging the wall tiles and spawning the collisions later, we can minimize the amount of colliding entities. Okay. Algorithm used here is a nice compromise between simplicity, speed, and a small number of rectangle colliders. Basic terms, it'll consider where the walls are, combine wall tiles into flat plates in each individual row, combine the plates into rectangles across multiple rows wherever possible, spawn colliders for each rectangle. Okay. We might have to go this direction because, I mean, let's look at what they do here, but we might do something where when we've added a wall or added a collider. No, I'm sorry. In that thing where we're spawning the wall colliders, we might want to loop over that could be exponential algorithm. I was going to say do something similar to what they do here and like try to combine. But let's see what they do. So this represents a wide wall that is one tile tall, used to spawn wall collisions. Okay. And this is, yeah. Yeah, one thing I would check is if your world is actually at 0, 0, if the issue is only a few pixels, shift downward. Let's look. And that is another thing that I don't completely understand about LDTK, but so we have set at 0, negative 1200, and I think that had to do with how it was spawning in the world. We could set this to 0, 0, in which case it's 0, 0 is at the top left, which is kind of weird to me, right? Let's see the world. World coordinates are 0, 0. Right, we just did that. So if I did negative 1200, that moves it to the upper right, and I think that fixed some things last time that we played with this. Top right is what I'd expect, yeah. Okay, let's look at their example here. Maybe we can figure out what to do. Okay. So, what are their queries? They've got grid coordinates and parents for an added wall, which is interesting because we couldn't get grid coordinates in a derive for int cells, but I guess it inserts it anyway. Okay, so maybe we'll try that. and they have a parent query, which is so parent would be um, okay. So that's a something to do with the project data. Okay, and then they're looking up parents that do not have walls attached to them. So if you had anything that was a nested entity, this would let you exclude things that might fall into this query, which is probably why uh, Bevy was wanting you to do that. Okay, then you're getting the levels, so the entities that represent the levels, and the projects and the project assets. And we saw this before when we were looking at trying to contain the camera within the level. Um, this is a similar thing, a similar set of queries here, these last three. Okay, so then they've got a plate which represents the left extent and the right extent of a wall that is one tile tall. Okay, and then they're trying to combine those into these, which are um, combine top and bottom as well as just left and right. Okay, consider where the walls are, storing them as grid coordinates in a hash set for quick, easy lookup. The key of this map will be, I say hash set, and then they use a hash map. Okay, the key of this map will be the entity of the level the wall belongs to. Oh, I see. So it's a hash set inside a hash map. So this is making making it possible to have multiple levels that and spawn colliders. Okay, so two consequences of resulting collision entities. It forces the walls to be split along level boundaries. Okay, fine. It lets us easily add the collision entities as children of the appropriate level. Okay, so this is about adding them as children of the level, not as just entities free form in the world. That makes sense. Okay, so again, we're looking at the grid coordinates of every entity that has the wall component added to it. And okay, so given the grid coordinates and its parent, okay, and that's so this is getting the parent from I'm assuming this parent.get is giving you back an entity ID. Yeah. Okay, so if there is a grandparent, an InkGrid's tile direct parent will be a layer entity, not the level entity, right? That makes sense. To get the level entity, you need the tile's grandparent. Okay, so this is why they have that extra parent query. You're trying to get the level to be the parent of the wall colliders. Okay. So then it's going to, get this and insert the coordinates of that. So it's just collecting all the walls for each level. Okay, and then so we're going to iterate over the wall query again. If the query is not empty, then loop through all the levels. And if there's a set of walls for that level, so that's what that if let sum is on, and this was the hash map that they created earlier. Okay, then they're going to get the project asset, right? So this is going to panic if there's more than one project loaded. Okay, so then they have that, and it say as standalone. I don't know what that means. We'll look that up. And then it's going to look for the level, the loaded level by this ID. Okay, and then it's going to get the layers, layer instances for this level. So what's interesting here is this is it's not it has to do with the LGTK format, file format. This looks like there might be because we can look at the layers. We have this int grid layer and we have the entities layer. I wonder if there's a layer that you can't edit, which is just the level dimensions. I guess we'll see. It might have to do with their particular design of their level. So we'll see. Okay. So combine wall tiles into flat plates in each individual row. Okay, so they're looping through. They're looping through the entire layer dimensions, creating a plate for each row. Remember, a plate is a single row, left and right. We'll see what this plate start is. Okay, so no, they're getting all the plates that will be in this row. This is what they're going to collect here. And then they're going to loop through X plus 1, so the algorithm terminates plates that touch the right edge. Okay. So they're going to go up to the width plus 1. I don't know why they didn't do ... equals here. That's a little weird to me. Okay. So if the walls for this level contains these grid coordinates, then they're going to push a plate on. Okay, so let's assume this is the first iteration. This is going to be none. Plate start is going to be none. And then if there is a wall there, then it'll say plate start is sum of that width, that position. Okay. And then if there already exists a start point, this looks like it wouldn't extend an existing one. Oh, okay, I see. So as long as this, yeah, I get it now. So if there was a place where we started and we reached a point in our iteration across X where there's not a wall there, then you end that plate. That's what this is. Okay. And then you set the start to none again. So if there's a gap in the wall on that row, then you would end that plate and keep going until you start a new wall, which would be this branch. And then if there's anything else, you just don't do anything until you reach an endpoint on either side. Okay, so now they've got plate stack, which is vec of plates. Okay, so then it's combine plates into rectangles across multiple rows. Okay, so we have a hash map of, that's interesting, plate to rectangle. And then they've got the previous row and this collection of wall rectangles. Okay, so right. Okay, so they're plate stack push this. So you've got an empty one. That makes sense. Okay, so looping through Y in the plate stack. So the plate stack is a vec of plates. And then they're enumerating. So that's like 0 to whatever the max y is. That makes sense? Okay, so keeping track of the previous row, looping through that, if it contains what's previous. Okay, so this is if the current row does not contain this plate. Oh, right, because you can't, this is not optimal, obviously. They're just trying to say if there are rectangles of the same size on each row, then you want to combine all of those. But if they are like non-uniform, if they're different sets, it's just going to leave it as a separate separate rectangle. Okay, so if the current row doesn't contain the same plate, remember plates are just x dimension bounds, then so the same plate in the future starts a new rectangle. Okay. So they've got this current row. Okay. It doesn't contain plates from the, okay. Then it'll push this new completed rectangle. Okay. And then looping through all the plates in the current row. So that's why this is used as the key. Okay, and then it's adding 1 to the top. So this is going from the bottom up, I'm guessing, based on the way that they're working with the coordinate system in here. Or inserting it as the bottom and the top are the same, and the left or come from the plate. Okay. And then going to the next one. Okay, finally the fun part. Okay, so spawn colliders for every rectangle. Making the collider a child of the level serves 2 purposes. Adjust the transforms to be relative to the level for free. Okay. The colliders will be despawned automatically when levels unload. That makes sense. Which is interesting. We may want to do that as, I don't know that we'll have multiple levels yet, but we may want to spawn, for example, our ghosts as children of the current level. We're already spawning the player as a child of the current level because it's spawned by LDTK's integration. Okay, so they insert a collider cuboid. What's interesting here, I think, is the math. They're doing right minus left plus 1. Okay. Times the grid size. Let's see where this grid size comes from. Oh, it comes from the layer instance, right? Okay. And then divided by 2. And this may be the key difference here. Top minus bottom. Okay. And then so that's their collider. And their transform is basically, I don't know why they did this like differently. Why they did the as F32, and then they do it on the outside here. That's kind of weird. Okay, but they're basically doing a similar calculation here. Left plus right. That's interesting. So this is I think it would be interesting to know what this cuboid, what its arguments take, whether they're like half extents or something. This transform is really interesting to me because they're adding, not subtracting here. and then dividing by 2. Okay. From XYZ. Okay. Yeah, it's not clear to me why that is adding rather than subtracting. I guess what I would expect is, oh, that you would subtract the larger, you subtract the smaller end of the from the larger to get the width or the height, right? And then you would have to add the smaller dimension back. That doesn't make any sense. So there's some vector math here. Always a brain. Okay, yeah. Okay, so you could think of it like take the. Now that still doesn't make sense to me. So you could think of it like, let's just say on the x dimension, you'd want to start at the left and then move half of the right. You'd want to move the center to half of the right minus left. So that'll be 1/2 of. Let's get a new buffer here. New. Okay, so it'd be L plus R minus L divided by 2. So if we distribute that, that would be L plus R2 minus L divided by 2, or L. That's where they get it. Okay, so the math is right there. I just had to prove it to myself. Okay. It looked strange. And again, I also don't understand why they do all this conversion here and they don't do it like this first. But that's not for me to know. Okay, so we could probably do a bundle in this case. And it's also a question to me why they do spawn empty and then insert a bunch of components. It's probably that this is based on an older API. But this is, I think this is sort of what we need to do. So let's crib a lot of this. I think we at least want to get the collision boxes correct. And then we can look at adjusting the tops and bottoms, lefts and rights of them so that they make more sense with the visual of our tiles. I think that that's probably the best thing to do. Okay. Let's save that. All right, so let's make a new wall colliders. Based on what they've got. And do they take commands here? Yes, they do. Okay. And we'll do something similar to this. Yeah. Hello, iSense. Welcome to the stream. We're figuring out why our wall colliders are all wrong. So we're going to do this like they do. Okay. So um, let's go ahead and do these. I honestly feel like I could copy most of this, but we'll want to adjust what entities are created down here. I'm sorry, what components? So let's copy pasta. I'm in the mood to fix this and not be very concerned about. Um, I'd rather copy and modify right now. Okay, so they figured out how to do all of that. What we want to do is um, and this will be interesting for our wall component. What we might want to do is, because this comes from the int cell, right? Maybe what we want to do is rename this to wall tile, and then we can make a wall component for let's do it like so, um, and I'm going to go ahead and copy all this, because what we don't want is we would like all of our existing tests for collided with a wall. Um, we want that to be different than the tile that's loaded in, because they're going to be a different entity based on what this algorithm that they have in the example does. Okay, so we're going to have to fix some of this. Import that. Okay. Right. Okay, so now what we want to do is we're going to we're going to spawn a, why does it keep giving me that? That is so weird. Okay, I just want to spawn a tuple, and we'll recreate this stuff. And we might be able to use a spatial bundle instead of this manual insert of transform and global transform. But let's start with, we're going to insert wall, because we're not, we're treating the tiles separate from the actual colliding walls. And then we're going to make a collider. Yeah, Chris, you said, I started putting together a Bevy newsletter, and Bevy 13 was not the right week to do data entry for the first time. Yeah. They changed a lot in Bevy 13, 0.13. I have not updated this project because I'm not sure that ECS LDTK works with it. I'm guessing not. There were some significant things in there. They look great. A lot of things that I am not familiar with, but looked pretty cool. Let's look at what constructor we want here. I think we just want size for now. We're not going to bother with the offset, right? What we can do later is figure out what those should be. So we'll just do the size of the tile size, really. Now this is a difference between what we've got and what our what the Rapier 2D does. It uses, like, this positioning of this collider is independent of the parent entity. So, but we're basing ours on the center of the entity's transform. So, yeah, we'll go with that. So, we'll say splat tile size. Yeah. except that's not, is that right? That takes a vec2. Tile size is an I32. Okay. Okay, and then we're going to do a spatial bundle. Field struct fields, and we only care about the transform, and we'll put the default on the rest, except too many dots there. Okay, so the transform is the part that we want to crib this from. And this is actually grid size as F32. So similar to what they did on here. Okay. So let's copy this. And uncomment that. Okay. Cool. Right, so we didn't have to insert the transform, the global transform, because they're handled by this spatial bundle. So we only did the transform itself. Let's try this again. We're not doing this special thing, but we'll leave that there for posterity. We will want to eventually bring back these tweaks to the collider size. So maybe what we'll do at some point is look at whether the maybe look at the tags on those tiles, such that we could adjust the rectangle of the collider based on whether there are, you know, particular kinds of tiles there. All right, but let's go with this. I want to see also right, so this has got to be added wall tile as well, not added wall without wall tile. Because we were treating the tile, again, we're treating the tiles separately from the walls themselves. That means we don't have to change any of the other. Right, tile size, fine. We're not using that. Okay, so there's the collider on our player. If we go up, hopefully we get up here to a wall. Interesting, it's only drawing one. Let's see if we can walk, if we, so now we're actually coming up against the wall, but, right, so we're gonna have to adjust that. So you can go around it. That's better than what we had before. I think the technique they have there, thank you, Chris, for that suggestion, looking at the platformer example. So now we need to adjust the this. So this is not correct. What we need is something based on the width and height of the wall. So what we want is, let's start with wall rect dot right. So this is going to be similar. Okay, what I'm doing here is let's just put this out here. I think it'll make more sense for me. Times grid size. as F32. Okay. And we'll do something similar for the width, height. Okay, so what's wrong there? I have syntax error somewhere. Oh, equals. Okay. I'm sorry, I'm getting back to your question. iSense, what were you using before Rust for things that you now use Rust for? Well, I've used lots of different things. Most things I use it for right now, other than for fun, like we're doing on this stream, have been server processes. So I've done server applications in a lot of Erlang and Elixir. I've done it in Python and Ruby, in Node.js, and I would probably, for a lot of those cases, want to use Rust. The exception might be that sometimes it might be easier to ship something, for me at least, with Erlang or Elixir. But yeah, I would probably use it for that. Like the efficiency there is worth it. Tokyo is really great. There's good ecosystem around async and Rust. But we've got, obviously I have never built this sort of thing before. I think it's pretty powerful here, especially the type system is guiding us a lot. So we're not, we're not having to guess. We're not having to make stupid mistakes and rethink them, because the type system is helping us. Okay, so let's try this again. And let's go up and make sure that wall. Okay, so we can't see the green, but you can see the center of it. Let's see if we collide with it. No, we do not. Okay, so this is an off by 1 thing. We need to do +1 here, right? Like they did in the example, because it's, you can have the top and the bottom be the same, but that's not a 0 height wall. Right? So in their, right, so they add 1 in their computation of what the collider should be. So we'll do the same. And let's try that again. By the way, Chris, this was excellent. Thank you for suggesting. We're getting really choppy movement there, but okay, so now our wall is all the way across, which is good. Yeah, that was great. So we're coming up against the wall. We're hitting only 1, not like every single wall tile we might hit. That's a huge improvement. Okay, so now we could maybe go and look at collecting the tags of, because previously, if you look in our editor, let's see here. So on our tile sets, I had left, right, top, and bottom. So this is a left side wall. This is a right side wall. This is a top, so on the bottom. And here's the bottom. So you're looking at the bottom of a wall. Here you're looking at the top of a wall. So we have that. That's how our, we have the tile rules, and then they're going to get labeled. So what we could do is, as we're looping over the collecting the plates, let's see. We could potentially collect which tags are on those tiles. That might be a bit complicated to do today. Let's see. Because what I would like to do is, um, when we've got this running and we have we've loaded all the wall colliders correctly. I would love to be able to go, well, it's okay if the player overlaps by some set of pixels. Just visually, that's okay. It'll make for a little bit smoother navigation around the map. And then, so we would need to see as we're collecting rectangles, because this would apply to, let's maybe, as an example in our level, yeah, let's just draw some walls. So we could do, oh, that did not go well. I want to draw a rectangle. Okay, so that also didn't go well. Our rules are messed up. Yeah, we need to adjust our rules a little bit. But presumably you would have a set of top pieces here, and those would get their collider adjusted inwards so you can come up closer to it, right? And then the same on the bottom, you would get you would get it so that you can kind of come up closer. And yeah, it doesn't look right on here because it should be like this, but you can see that in this area you'd want to be able to come up that far. So what I would like to do, we're gonna delete this. What I would like to do is be able to draw something that is kind of out in the middle, not along the edges of the map, and we would be able to create the right colliders for it based on whether it's a left or right tile, a top or bottom tile, so to speak. So the effect of that would be to shift inward the top or the bottom dimension, or the left or the right dimension. So we might have a collection of offsets or something. It would be an offset as well as a dimension change. Or it might be, in this case, it might just be a dimension change because we've got, no, I'm sorry, it would have to be an offset as well because they're non-uniform. Anyway, let's see if we can fix these rules because that is just wrong. Okay, so we can probably oops. Control Z is not working. I forgot you have to hold shift to draw a rectangle. Okay, so let's draw this rectangle here and let's figure out what's wrong. So this is labeling as bottom, but we need that there. Okay, that's looking better already. And then let's look at the rules for this. Okay, so this is, what if we remove that? Then we get wall like that all through there. That's good. Okay. That is fine. I think we need to add one of higher precedence that makes this top corner. There's some weirdness to this anyway. We may want to change. Let's change this back, and we'll do something for this inner space that's slightly different than these. But we need to fix this top corner here, top two corners. Let's look at the rule for that. So that's just if there's nothing on the right hand side of this, you do this tile. Okay. So we need to add a new rule, which is there is a wall here, and there is a wall here, and there is a wall here, and there isn't here. And let's select a tile for that. And that would be like this, right? The top corner. Yep. Okay. So now we've got that one fixed. And we can mirror that in the X direction. So let's go back to the tile set here. Remember how we labeled these left and right? We need to label this one left as well as top. So, right? The downside of this is we've got, these are like mirrored, right? So we probably need to make a new rule that duplicates that one we just edited. Oops, we just created. So we created this one, and we mirrored it on the X. I think we need to duplicate it. And then we're going to flip these. And then we're going to use this tile so it gets labeled correctly. Okay, so now we've got that corner correct again. And then let's, this kind of looks weird coming down into this, but I don't know what to do with it yet. We'll figure something out. And then over here on our tile set, why did I, oh, okay. The zooming got messed up there. Okay, so we want to label this one right. No. I've got that wrong. This one needs to be labeled left. Left, right, getting confused there. Being like, the wall is to the right of you. Yeah, not the best word. That could get confusing. Okay, and so that's top. That also needs to be labeled top. So if we want to adjust the box that way. And then bottom, we're only doing that. But let's see. We're using... No, we aren't. We've got the corner pieces, which are... I think it's shift to drag. Just want to resize that so I can see it all. Okay. Well, we've got... I'm going to zoom way out. It's going to be really hard to see. We've got these things for the edges of the top wall. And I think that... Let's look at those rules. Yeah, we've got this. Maybe we don't concern ourselves with that yet. But you can see that that's just for the top inner corners. It would look nice to have that here potentially. All right, let's go with this. Oh yeah, let's make one for for these inner ones. So you've got walls on. You got walls on all 9, right? Let's make that rule. The other thing is, like, this is particular to the bottom, so we could just make a fallback rule, which is like, if there is a wall here, and we'll pick one to fill it in. I don't even know which one to pick. Maybe we do this. We could do something like this, so it looks like the top of something. I don't know how I feel about that. Feels a little weird. I'm guessing these are like stairs. I think that's what those are for. We don't have stairs in our game. Okay. Let's just go with that. And then, the thing that's strange about it is it's going to look like a tall wall. See, there's not anything else in here. Maybe we could do. Let's try this. I know that's not right, but that at least looks slightly different. It doesn't look like it has dimensions, right? Though, because what we would want is like some kind of scalloping on the top of this wall. If it's an inner one. So you can tell clearly that it's the top of the wall. Which would mean kind of like, one of these pieces, but we're already using those. So I'm not even sure what to do there. And interesting decals on there. Yeah, we'll just go with this for now. And it'll look janky, but we'll have an additional wall that we can play with in here. And then, at some point, we'll go and we'll actually make this level interesting, as opposed to just a blank canvas. Yeah. And we will make sure that this is getting a correct collider, and we'll be able to see it more easily because we're not having to walk all the way to the edge of the level. Okay, so let's go back to our game. And let's see. Yeah, so obviously, that's not a great collider, because it needs to be shifted. But we created a new wall there, and it got this collider put in the right place. So, yeah, let's maybe see if we can figure out how to build up a we want to keep this computation the same, but we'd like to collect what the tags are on each of the plates. Because the plate is used as an identity as well to combine rectangles from multiple rows of the tile map. So we can't really use that to collect the set of tags. Let's see what we can do. what we could do is we want, there's an entity here that is with the int grid cell. And I'm going to have to look back over here. And it is tile enum tags, which is that thing that we were doing in the editor where we looked at the tile set, and I hate that it does that. Why does it do that? Here, zoom in on the right side. Okay, so if we have, we have these labeled left or right, top or bottom. Those come through in this tile enum tags entity, or this tile enum tags component. So what we can do is they're looping through all of the wall tiles that were added. And this will have the tile enum tags, right? And we can set that to ignored for right now. What I'd like to do is collect a hash map. Let's call it yeah. So we're gonna do this is gonna be a hash map, and this needs to be we're handling multiple levels here, which is making it a little bit complicated. I'd rather not do that, but I don't see a way around it right now. I'm gonna put a hash map inside it because what I want. The other option is this is level to wall locations. We could change this to be a hash map, and then the contains would still work on it. So grid coordinates to let's see, what's the inside of that vec of string. Although we don't want, no, we want a vec of string. That way we can just copy it in there. Okay, so we're going to insert the grid coordinates on tags clone. This is tile enum tags. Let's name that. That way it's clear. Clearer. Okay, so now we're putting in there, and there's going to be potentially some problems we need to fix down there. We're collecting for each coordinate in this level what the tags are associated with that tile, right? In addition to, what are the coordinates of walls. So, right. Okay, so this should still work. It's basically the same, except we got a map here. Hash map of hash map is, not great, but it's what it is. Okay. So So hash map doesn't have contains. So what we want to do here is why does hash map not have contains? Sorry, I'll get this over here where we can all see it. Oof, that is big. Okay, so it has contains key. But probably what we want here is not contains, but get. And I think that what we want to do here is our plate stack should be a vec of plates. With a hash set of strings, which is making me think that what I want to do up here is not a vec of strings, but a hash set of strings, and then we can combine them more efficiently. And then we'll do iter collect. Right. So then this is going to be and what we'll want to do is something. So this would be none if there's nothing there, right? This is going to be sum, and the plate start is going to be and we'll need to push that. Pushing a tuple of that and plates or tags. And the plate start needs to be sum of x, and this will be, there will be some tags there, and then on this one what we're going to do this will be existing tags. We're trying to collect the new tags that are from each of the tiles in this iteration. So this will be, what we want to do here is go plate start. So it's going to keep the existing start point, and then we're going to look at hash set, see how we can merge those. Union. I guess we could use extend. I don't know how different that is from union. Union returns an iterator. So let's do existing tags. Extend. The thing is that's mutable. Right, so that like extends into the thing without returning a value, so that's probably not what we want. Let's do existing tags, union, tags, collect. Okay, so need to clone that. We don't need that. Let's see here. Viz is the values representing the union. Do I need to call cloned here? Yeah. Okay, so basically, let's start this over. None is not covered. Okay, well we'll put in the we'll put in the fallback one. We don't care about none. There's no start and there's nothing at that spot, so I guess we could explicitly handle it. Okay, so what we're doing is we're collecting all the tags across all of those rows, those horizontally contiguous sections of wall. And then eventually down here, what we're going to do is we're going to adjust the collider size for each of the plates, each of the rectangles. We will need to combine them also when we're iterating over rectangles. So our rectangle here, mapping a plate to rectangle, we'll need to map it to tags as well. And the previous row is this will have to change. This contains will have to be a bit more. It's interesting. Maybe it's what we could do is rather than having a vec of plates, since we want to compare on equality anyway, we could make that a hash map. And then it's slightly different. The other thing is maybe we can just leave that because we've already gotten through this part. We could rather than using contains, we could say find. And this is going to be, and we don't care about the tags in this case, but we could say previous plate equals current plate. Is some. I'm sorry, if current row dot iter dot find. Okay. So if there isn't one in here, so then we've kind of by-stepped the fact that we are collecting tags as well. So previous row is going to be a collection of plate and hash set string. Okay, so it's got the same type as one row of our stack. Okay, we've got to borrow that apparently. Okay, so this is saying if this plate, if the current row does not have this plate, So we need the rec builder to be um, I'm almost tempted to make a type alias of tag set. um, okay. Right. Okay, so now the wall rects are going to be a vec of rect and tags. This is a pretty deep change here. We're having to change everything. Luckily, again, type system is helping me figure this out, right? Okay, so now we've decided to push this into the collection. If the current row doesn't have the plate from the previous row. Okay, so now we're in the plates in the current row. And what we want to do is do this. And we want to do okay, so if we've got a rectangle for the current plate, we want to make sure that this is so when we modify it, we're making the union of those. So they're already doing like add add one to the top, right? That makes sense. But we've also got the tags in here, and we want to say t.extend tags. So that's going to add the set of tags here. Right, so that can be turned into iterator. This t is mutable. Cool. So now we need to make sure we insert the right thing, which is a tuple again, and we say tags.clone. Okay, let's see what's wrong there. Extent. Yeah, will you stop flashing? Thanks. Let's see what Rust Analyzer says. Okay. Expected string found. Type mismatch resolving hash set string into iterator item equals string. Okay. So that's a problem of it's not owned. I'm not going to really care that much about being efficient here. We're just trying to get the collection of tags there. Okay. So now we've got, here's the rectangle, and here's the tags for all the wall rectangles. Right? Okay. So now we've gotten to the the part that we actually wanted to adjust. So let's do Collider has one with size and offset, I think. With size and offset. So that's the width and the height, and we want to do offset, we'll say. And let's say let mute offset is vec2 0. So what I would like to do is we'll loop through the tags, and we'll match on that tag, and we'll do So remember, this is a set, so we're only going to apply these once. And what we'll do is we'll do the same sort of like size adjustment and position adjustment. So tag is going to be a string. Yeah, we can consume it. Let's do asref here. So it'll match. I guess we could also do borrow tag or borrow tags. Yeah, I like that better. Okay, so if it's left, we want to, if there's a left one, we want to subtract 6 from the width. Or I'm sorry, that's 10 from the width. It's only 6 wide. So we need to make sure this is mutable as well. And then okay, so width is going to be 10. We're going to subtract 10 from the width. That'll get us what we did here. And so note that will apply for the entire height of the rectangle, right? So that this is the sort of thing that we want to do to get it moved inward on the left. Okay, and then the other thing we did on the left one was we moved the center 2 pixels to the left, so that 6 width rectangle was 2 pixels off of center. So what we can do here is offset.x minus equals 2 as well. And we'll do something similar for, right. And I think that this should work because we are, yeah, and so we're going to add 2 pixels. So if we have both left and right, the x offset is not going to change, but we're going to shrink it by 20 pixels on the width. Plus, okay, so we need to do the width adjustment. And then offset.x plus equals 2. And then top, we'll do the same based on what we got here. So top, we have the size is decreased by 4 pixels. And the offset is moved upward by 4. That doesn't seem right, but we'll see. Okay. So the height is 4 pixels smaller. Yeah, we might have that backwards. We'll see. Plus equals, right? So we added 4. On the bottom, we subtract 4. And again, the bottom is also 12 pixels tall, so that's 4 shorter. I think that's minus equals 4. Yep. Okay. So the other thing I need to do here is that we don't do anything on that. So what's wrong here? Yeah, fine. As ref. I just want you to test equality. Come on here. Okay. So what this will mean is, our top and bottom pieces are 4 pixels shorter. Our left and right pieces are 6 pixels narrower. And so if we have that wall in the middle, all of its parts should be moved in to kind of hug the visual, with the exception of the top. The top is a little bit above the ridges, which is fine. But let's give this a shot. I have no idea if this is going to work. um, I'm sorry. Let's remove that info. It's not that helpful anymore because we figured out the problem was related to the tiles themselves. Okay, so we've got a problem here. Value of type hash set cannot be built from iterator over string. Oh, it needs to be cloned. Note that it's the reason I can tell that is that it's trying to iterate over where the item is a reference to a string. So we're in the wrong file. And that is way up here. We're going to cloned, collect. The other thing I could do is clone the vec and do into iter. Into iter. There's probably some other way, like hash set probably has a, well, I mean, from iter is collect, right? So we don't need to necessarily do that. Yeah, it's fine. Okay, let's see about that. What's wrong here? Okay, so use a moved value plate start. Oh, so there are cases, I guess, here where we're moving it and we're not replacing it. So this would be a use after free problem if we didn't have a great compiler. Okay, so we're moving it here. Okay, let's look at this. Plate start value moved here in previous iteration of the loop. I think it might be that we need to do none. And here say plate start equals none. Because we're setting it on all the other branches. Yeah, the other option would have been to borrow it. Let's see if we can borrow it and save ourselves some trouble. It might have overlapping borrow problems then. Yeah, and it's actually, we do want to move it. So we'll just do that. We'll set it on every iteration. It kind of sucks, but the main problem is we needed to collect those tags. The other thing we could have done is made a different mutable variable for the tags and just set them when we reset. So like after we push. I don't know that it matters. It's fine. Not the clearest, but it's fine. Okay, so now we only have warnings, it looks like. Yep. Okay, so interesting. Look at this collider, though. We've got a problem there. I think that we've got the right... that's not correct. The top is not correct. We got an issue with this whole thing should be walls, right? and that is not, we messed up that iteration. I'm fairly pleased. Yeah, and this is also incorrect. Um, I'm pleased with the left and right walls. They look a lot better, but I think that they are also slightly incorrect. So let's look at this. We've got a problem here with how we're computing this. We messed something up along the way. Okay, so this is, I'm going to start putting comments in here. This is the end of a wall segment. So there's nothing in this spot. So when we have that, we have the starting point and the tags. Then we push the plate with its tags. And this next one is the start of a wall segment. Right? This is continuation of a wall segment, collecting all the tags. And this is still not a wall. So this would be, I think I'm going to be explicit here now and say we don't have a wall started, and there is none at this spot. Yeah, I don't see why this would mess up. Unless what we're doing here, now we got warnings down here. What's wrong? This Boolean expression can be simplified. Okay, so this is probably like any. Not is find is some. Let's start with that. Okay, that's what they're complaining about. Thank you, Clippy. What if we did this? And we can remove these dot zeros here. Can't compare plate. Okay, well, don't double borrow it then. Okay. And don't double borrow that. Okay. Yeah, the weird thing here is I didn't change any of the. I mean, I think it's in here, right? It's in here that we made most of the changes. The rest of it was just reading what was changed there. And then extending an existing rectangle with the tags. What's interesting to me is that it came out that what it looked like was happening was there was some aspect of the tags being different that meant that it was created in a rectangle when it shouldn't have. Another possibility is that what we want to do is it's possible that, this inner part, these aren't labeled at all in our tile set. So they might not have tags on them, which means it won't insert an entity for it, or a component, tile enum tags component. I think that might be the case here, and what we need is a tags query, which is going to be tile enum tags with wall tile. And then we'll remove it from this query. Okay, and this is what we'll do here is we're going to need, on that wall query, we're going to need the entity, because what we want to do is look up, what is this entity, does it have tags? And if it doesn't, give it a default. So we're going to figure out how to do that, and I'm going to pull this out of there. This is not how it's going to work, but this is going to be entity. Then I think, yeah, okay. So what we want to do, well, it's essentially that, but we're going to do tags query get entity. So if it has tags, we're going to map those. So this is going to be tile enum tags. And that's going to be a reference to them, right? So we want to do tile enum tags.tags.clone. And then we want to do into iter int collect or default, unwrapper default. So this is going to be here again, hash set of string, right? And then we'll put tags here. Okay, so the problem was we were not registering these as, they didn't fit that query because they didn't have any tags on those tiles. So what we want to do is, even if they don't have any tags on those tiles, they still should be a wall. So we don't want to exclude them from the wall query, but we do want to be able to get the tags for things that have them. Now you might be able to do, let's look at Bevy's, I need to wrap up soon, but let's look at Bevy's queries. We might be, where's that Bevy cheat book? Bevy cheat book. We might be able to do option of tags. Okay. Let's see. So like you could still be part of the query even if it doesn't have that thing. I don't know if that's a valid. queries. Yeah, you can have option. So let's back this out a little bit. Because I think I made it too complicated thinking that you had to look it up with a separate query. And what we're going to do, yeah, put that back in there. We're going to make option of tile enum tags. And then we will do that map stuff that we did. So now that's an option, right? Map t.tags.clone.into iter.collect unwrapper default. And then we can get rid of this. Let's say tags. Okay, so this is a hash set of string like we did before. Yeah, that's better. I prefer the option in the query. Then we're not, yeah, we don't need this tags query because it's superfluous. We don't need to do a separate query. We've already got the tags that are there. Let's try that and see if the walls get contiguous again. They should. And hopefully we didn't break anything. So far, so good. Okay, so that's looking more correct. No, we can come up all the way to the edge of that. I'm not allowing us to get too close to the top of the wall segment, but the player can overlap a little bit on that bottom side. So I think that accomplished basically what we had wanted from previous sessions. Let's run it without the gizmos and see. See what it looks like when you're just running up against it. Like that makes sense. And we can do some tweaks there. Maybe we can let the player go a little bit over the bottom part of the wall some more. But note there, we'll probably have some corner stickage issues, which I've seen in other game developers' discussions of collision systems. But and then there's maybe we can let them get a little bit closer to the wall on the top side of it. And our ghosts are just trying to kill me. Okay, so that's I think a good place to stop. Let's look at what we changed here. Okay, I'm going to skip past that. That's just the project file. Okay, so we redid the wall collider system, and I think I can delete the comments on the other bits. So let's do that. Now that we have that up there, and we can adjust the dimensions of those wall colliders as we see fit in this area. Okay. This past week I started to try to use GitHub Desktop. Not really that much of a fan of it. Unfortunate. Could have been so good. But nothing compares to Maggot. I just haven't found anything, unfortunately. If I wanted to do interactive ad, that was always the best thing. It knew exactly how to stage exactly what I wanted. Okay, so let's make a commit for this. And we're going to say this is session 11. Fixing wall colliders. Thanks to, we're going to call out Chris. Thank you, Chris, for coming and for giving me that tip. And the Bevy ECS LDTK platformer example. Okay. Pretty good place to stop. Thanks for coming. Thanks if you stuck around for the whole thing. And we will see you next time. I hope you're enjoying some beautiful weather like we are here in Kansas City. And otherwise, we'll see you next week. Cheers.